Hello guys, today we're going to take a look at adding some more LEDs to our Siku Control 32 electronics. Today we're going to add some beacons to the tractor. So again, I'm going to use the control board from the John Deere 6920S. So all of the circuitry is the same as in the last video. All I did was remove the floodlights that we had added before and put the headlights back here. So this is over this side is basically the circuit that comes in the tractor. I've just put different LEDs on it, that's all. The piece that we're adding today is over here. So what I have here is a 556 timer, and I showed in a previous video how to set up a 556 timer to give you both a warning beacon type of flash or an indicator flash speed. So if you want to figure out the circuitry for that, you just head over to that video. It's done in a bit more detail. But just to very quickly recap, we're getting our frequency by combination of a 1k resistor, a 10k resistor and a 10 microfarad capacitor, and that is giving us a frequency that's roughly around what warning beacons would be. And again, the equation for all that I talk about in the other video, so you can look that up. So let's take a closer look at the LEDs we want to light up. So we have two orange LEDs here, and each LED has a resistor. These are 470 ohm resistors I've just decided to use for this, and all of these are connected in series. So we start with this LED. Its positive leg is connected to the VCC, then its negative leg goes to the first resistor. That resistor is then connected to the other resistor, and that resistor is connected to the positive leg of the second LED, and the negative leg is connected to ground. Where the two resistors meet in the middle, that is connected to the output of our 555 timer. So when our 555 timer output goes high, we turn on the LED that's connected to ground, and no current flows to the LED that's connected to the positive, because our voltage is the same at both sides, or pretty much the same. So then when the signal goes low at the output of the 555 timer, then our current flows from the positive leg here of this LED through the resistor and is synced through the 555 timer. So we can't obviously put a huge amount of current through the 555 timer. I can't remember what the current is. It's probably around 20 milliamps or something like that. But it's more than enough current to light our LEDs. So that's a fairly straightforward circuit, and if we give it power, we'll see that our LEDs are alternating, which is what we want for our warning beacons. So the next thing we want to do is connect this circuit to our Control 32 main controller board. But if we just connect the VCC and ground rails on both the timer circuit and the Siku Control circuit, then when we plug the battery in, our warning beacons are just going to flash all the time, which isn't what we want. We only want them flashing when the vehicle is active. So we need to connect our circuit to a signal that's going to come to life when the controller makes a connection. The problem is that the signal that we're going to use to switch this on wouldn't have been designed to supply enough current to power our 555 timer and our LEDs. So we need to use a PNP transistor as a switch to turn on our timer circuit. So we're going to take our VCC connection for our timer circuit and move that over to the collector of the PNP transistor. The emitter of the PNP transistor is connected to the positive rail, the 3.7 or whatever voltage your battery happens to be at. That's connected there. And then the base has a 1k resistor that's going to this wire, which I'll show you when we switch it to ground here. We get our LEDs flashing. So why did I use a PNP transistor instead of an NPN transistor? I could have easily put an NPN on the ground line and done the same thing. Well, if you remember back to some of my other videos, we did come across a signal that goes low when the controller makes a connection, and that was the signal that put the servos into sleep mode. So it goes low when the servos become active. When that signal is high, the servos are inactive. It turns off the motor drivers. So we are going to take this connection and connect it to the sleep mode signal on the servos. So I've disconnected the battery to show you what happens when you turn on the battery, but I'm going to connect our signal wire to one of the sleep signals on the well, one of these two lifting arm servos. I'm not sure which is which. Okay, I think that's in the right pin. So when I connect the power, we should see our timer flash with the other LEDs as the control board kind of initializes. So you seen there, our headlights and brake lights came on, and then our little warning beacons went through a few cycles. So now if I get the controller and turn on the controller and connect to our circuit here, so this circuit is powered on. This is as if you just picked up your Control 32 tractor, you hit the power switch, and now you're about to switch on the controller. So I'm going to connect to the tractor now. And you can see when we connect, our warning beacons come to life. So it's only when the controller connects that our warning beacons are turned on. So we can turn on our other LEDs and hit our indicators, and everything is working fine. Steering servo, have our motor, so everything's working fine. Now if I disconnect again, our lights all go off again. So maybe I'll just connect and turn on the headlights. So this is what would normally happen. So you're familiar, the lights will go out on your normal Control 32 tractor when you disconnect with the controller. And that's exactly what happens here. And if we go back in again, they'll come back on. So there you go, that's what we'd want. The lights are only on when the tractor is in use. So I hope you found that video interesting. If you did, make sure and hit the like button, and if you have any comments or suggestions, let me know below the video. I'm not sure if there's anything else that would be interesting that we could do with this circuit, but if I think of anything, I'll do it in the future. And if you have any ideas, let me know in the comments. But I think that's pretty much everything, so thanks very much for watching.